Hello, welcome back. In example number 2, we want to find the volume. We're looking for volume of revolution. So we want to find the volume of a solid formed by revolving the region of this parabola 9 minus x squared, the bounds x equals 0, x equals 3, and y equals 0 about the x-axis. Now, in our notes from beforehand, we said if we're going about the x-axis, we're going to be in terms of x. So we want to keep this as a vertical rectangle. So, all right, so here we go. And the first step is to just graph it. We have the graph of 9 minus x squared, and that's pretty easy to graph. It's just a downward facing parabola, right, like so. X equals 0, well, that's just the y-axis. X equals 3, which is just where it meets here. And y equals 0, which is the y-axis. And the region we're looking to shade here is going to be this little piece right here. Because remember, we want to be bounded by all of these. And we're going to revolve this around the x-axis. So I'm going to draw my rectangle of mathematics. And to draw my rectangle, remember we talked about this before in the previous video. To get the radius, we are going to find the distance between the function and the axis of revolution. So I'm going to go ahead and do that. So if I start at the axis of revolution, I measure up to the function, and there it is. There is my rectangle of math right there. There's our rectangle of math. When I revolve it, this is going to give a disk. Now, I know I'm going to revolve it because I am revolving it. So this is my disk method right here. So I'm going to draw my disk, right like so. It's going to have a radius. Well, that radius, because we're vertical, again, is top minus the bottom. The top function, if I look at the top, well, what's on top? It's my parabola, 9 minus x squared. Minus the bottom, well, that is just my x-axis, which is y equals 0. So we're just going to get this 9 minus x squared. Now we got to get the height. The height is just the thickness, which is just our dx for now. So I'm going to write this out. My volume, my formula, whoops, that's a weird looking pi, is just pi r squared h, because this is our disk method. To get pi, my radius was 9 minus x squared. I'm going to square that, and my height is just always going to be dx. To get my volume, I'm going to square this. We're going to get 81 minus 18x squared plus x to the fourth. I'm just going to go ahead and expand that, but now I'm going to go ahead and integrate this one, and we only want to do the bounds between 0 and 3. That's all I'm interested in, between 0 and 3. Solving, we're going to get pi. This is 81x minus, this becomes, 6x cubed plus x to the fifth over 5 from 0 to 3. And it ain't going to be pretty, but, that's okay. Doing the first one, 81 times 3 minus 6 times 27 plus whatever 3 to the fifth is over 5 minus, oops, let me refix that here, make that look a little bit nicer, minus, plug in your 0, remember this is just f of 3, minus f of 0, which is neat, 0 minus 0 plus 0. And honestly, leave it alone. Do not simplify it. Just leave it like that. It'll take you longer to simplify that than to do all the other work. All right, so let's take a look at a slightly more challenging one. Number 3 here. Now, number 3, same thing. We want to find the volume of the solid generated by revolving the region y equals x cubed, the y-axis, y equals 1 and y equals 8, about the y-axis. Now, be careful. We're going about the y-axis, so we have to be in terms of y. And therefore, we're dealing with a horizontal rectangle of mathematics. So first, let's just draw it out, see what it looks like. Y equals x cubed. We're only interested in the first quadrant, sorry. So it kind of looks, sorry, that's a terrible looking one. There we go. So it's going to go like this. It really kind of looks like this. But I'm only interested in, with the y-axis, my other bound y equals 1, y equals 8. So I'm only interested in this region. right here. I'm going to revolve it about the y-axis. So I put my curly key on the y-axis right here. So what I'm going to do is I'm going to draw my rectangle of mathematics. Remember, we're in terms of y, so we want a horizontal rectangle. So measuring from the axis of revolution, I measure out to the function, right like so. And if I revolve it, notice I have a horizontal disk. So my disk is now going to be horizontal, like so. But remember, the height is just going to be dy. That's my skinny part. It's dy in this case right there. Okay? So if we set this one up here, our radius is just going to be right minus left. And on the right, there it is. On the right, we have our function, but you got to be careful. We have to be in terms of y. So I have to solve this. So if y equals x cubed, I know x is just the cube root of y. So my right is going to be the cube root of y, and on the left, we have the y-axis, which is just x equals 0. So my radius is just going to be y to the 1/3. And that's what I'm going to set up. My volume, pi r squared h, pi, my radius, y to the 1/3 squared. My height this time is dy. My height always is d something, whatever variable we're in terms of. V equals pi. This becomes the integral y to the 2/3 dy, and we would evaluate that from 1 to 8 because we're already in terms of y there. So integrating this one, we get pi. This becomes y to the 5/3 times 3/5 from 1 to 8. And our answer, using the FTC, I'm going to pull out the 3. We're going to get 3/5 times 8 to the 5/3 minus 3/5, 1 to the 5/3. And we can probably clean this up a little bit. We're going to get 3/5. The cube root of 8 is 2. 2 to the 5th is 32 minus 3/8. Whoops, that should be 3/5, not 3/8. That should be a 5 and not an 8. That one's pretty nasty. All right, so take a pause here. We'll go into a few more examples. I'll see you then. Bye-bye.